Hey everybody, just checking in. I have a kind of a fun one, a little bit of a divergence from the usual mechanics. I did a little bit of work on some environment um, generators. And basically, what I mean by that is, I'm making a space game, and I probably have a need for making a lot of debris, space debris like asteroids and other things like that. So I made some classes to help me generate that. I was originally kind of templating things with something like this, which I'm calling a rock field, which is really just a first pass. And it's all in blueprints and it's pretty simple. It's a lot of random streams. And when it gets constructed, you basically output a bunch of rocks and you have to add a bunch of instances. In this case, I'm using instance static meshes, which are much faster to render. You can render so many of them. But I may also want to be rendering static meshes so that they can have some physics. But anyway, this is kind of the first pass. It's controlled by minimum distance, maximum distance from a point, and certain scale multipliers. So it tends to have a density around the center of where it's put. Like so, already put one up here. I'll make a total of 50, and I probably need to select a mesh somewhere. I didn't really do a good job with this one, did I? 5, 1, stream, rendering, static mesh. Let me just like rock. So now there it is. So that looks pretty good. That's not bad, but it is giving it a little bit more density towards the center, and it's only going to work when it's a sphere shape. It's only really working for a sphere shape. So I was trying to think about ways I could make that better and kind of show you the sphere shape a little bit better. If I go to the properties of it, bump that down, you can kind of see what's going on here. Minimum distance, maximum distance. What's kind of cool, since I'm using a random stream, you get these sort of consistent results about where things are. Even when I drop down the numbers. So if I find a setup I really like, I don't have to redo it. And when I move it around, it doesn't recompute because it's doing it from a random stream. If I want to change that stream, I can just go in here and change the seed. That's really helpful, really helpful. Anyway, so that's the first pass. Second pass is a C++ class because I wanted to do a little bit more complicated stuff. Basically, I wanted to make it so that I could have a shape that I say I want to fill in with rocks with even density, or maybe not an even density in the future, like maybe there's some density function. But for now, I kind of just want it to be a shape I can fill out like a torus or something. So I can make little like rings for planets and things like that. I wouldn't really be able to do that with my rock field. So I made a mesh generator. And it's kind of in a debugging mode right now. Let me just bring it to like, whatever, that's good enough. So you give it a template, which is like the brush. No, sorry, the template is the rock. Probably I need to name these a little better if I'm still confused. And then you give it like an exterior. So it would be like, I have exterior for a box. I'll explain some of this. And then I have interior for a box. Maybe I should just rig these up automatically so I don't have to do some stuff here. But here's kind of what's going on. It's basically going to take the interior and exterior and use those as collisions so that I can do an inside-outside test. So here's what I'm talking about with inside or outside tests. It's very simple to implement, and it works on concave and convex shapes. So basically, if I'm given a point X that I know is outside of my shape, I can test any point by saying, drawing a line from here to my definite outside point, how many intersections do I get? So this time I got 1. What about this point? Okay, so this time I got, whoa, nice line. This time I got 2, right? So the way that you turn this number into inside-outside is by saying the number of intersections, let's say I, and then mod 2, If it equals 1, then that means I'm inside because I've gone through one wall. And if I've gone through 2 walls, that means I'm outside. And that's basically it. It's really simple. It kind of shows what's going on. Red means it's outside. Again, green is inside. And you can see what's going on. It's kind of cool. And you can kind of see I could build some more complicated shapes with this. I kind of need to explain why I need to do an interior and exterior. Well, that's because the way the line trace is working, here it is generating the templates for the number of things that I'm trying to generate. Here's a random point from a seed or from a stream, where I'm just picking random points inside the box extent. But basically, when I'm doing a line trace, here it is, line trace multi by channel. I'm basically taking this line and seeing what it intersects, and I have specific collisions for this generator. They're all overlapping so that I can intersect multiple things, because actually, when line trace by multi hits the first blocking, it returns true, and it stops aggregating into the hit results, which is what I want. So, or I want hit results. So actually, if you're used to saying, bool intersection, and then testing that, you're going to get the wrong results because it's never going to really be done. It only returns true when it's done. It's kind of a weird API. Anyway, the point is I have to iterate over these hit results because otherwise this always returns false because it's always looking for overlaps. Little annoying. But basically, when I get a result, I want to make sure that it is either the interior or exterior. Now, since objects, let's just go into Blender. Easier. Since the way that 3D graphics work, you have like a back face and a front face. So even though this looks like a solid cube, when I go inside it, it'll probably render something, but this would not render in Unreal, because this is a back face. You can see the shading is a little bit off to help me see that it's actually the wrong side. You can also like debug it with, you can put on here you go. So I just gave it some normal so you can see which side it's facing. And I don't even know if I should explain so much here, but you can see they're not here. Here they are here. The whole advantage is that when the camera's pointing at something, I just don't even want to consider these back faces, Like I don't even need to think about them because they're back. They're not even facing the right way. So that's useful. But for me, when I do a line trace, if I were to do it with just like I think I set up a line here when I was testing. Basically, when I just put a thing in there without a front and a back, it only gets one hit, but I need an interior hit and an exterior hit. So here you see the 2 hits. That's because the one going in is intersecting the exterior. The one coming out is intersecting the interior. So I need 2 meshes that are the same, that are flip normals. So for example, let's just make a torus. Oh, wow, that looks real spiky. Okay, fine. And I'm just going to export that as an FBX inside my Blender, inside my assets, inside geometry. And I'm just going to call it SM torus exterior FBX and export. Okay. And now I'm going to go flip normals, and I'm going to go export FBX. I could probably have done that in one go, but I'm going to call it torus interior FBX. So these guys are the interior because they're all pointing in. Pretty easy to understand, I think. Well, it looks a little messy, but you get the idea. I can just close that now. And then I'll import them into Unreal. From the geometry. And I got the exterior and interior. I'm just going to drop them in, import all. There they are. If you drop the interior in, you can see it's a little bit of a mind warp because I'm actually seeing through this face into the internal faces from far away. It looks a little bit like it's moving, kind of a cool trick. Maybe I'll use it someday with something. I don't know. Yeah, so that's the interior. That's the exterior. So you can kind of see what's going on. If I want to intercept on my way out, I need to hit the interior. So that's what's up. I'm going to go in here and go into, before I do that, actually I need to assign some default materials to this so that we can actually see through it in both ways. What did I call it? Like just translucent. Transparent. Why is it not happening? Transparent. Okay, because I just typoed it. Got it. Transparent. Okay, so that's just so I can see through it for the testing cases here. And so now I'm going to change the exterior test to the torus exterior and torus interior. Now it's got like a crazy logic here. So I have actually two meshes. One is exterior, interior, and also two static mesh components in my C++ so that you actually can't intercept the same object twice. Even if it's got two normals flipped, it seems like it doesn't return. So that's something else. So I have my exterior static mesh, interior static mesh, and then I fill them out with the actual meshes. Okay, all right, so let me bump the number up to maybe like 50. And it seems like I have some problems here, doesn't it? It sure does. What if I just move it? Maybe it just didn't really build. Okay, yeah. Not sure what that is. It just didn't rebuild when I set the static mesh here. But this is working very good. I'm going to make it a little bit bigger, maybe, just so there's a little bit more area. Looks very messy from all the debugs. And also the mass distribution, it doesn't know where the shape is necessarily, so that's a little bit of a problem. I'm going to have to turn debugging off, actually, before I continue, because it's just too much performance hits. So I'm just going to get out of here with all these, and I still like the box, and I don't need that anymore. Okay. Cool. Let's see if this is going to work at all. Yeah, it kind of works. All right, am I frozen with that? Not really. So that still works. I'm not sure why the distribution's so low over here, but this is exactly the result it is actually that they're there. I'm just not seeing them or something. I'm not really sure. Things seem to be speckling in and out. So obviously it's not the most efficient because I'm generating a lot of points that I'm not even using. But I don't really want to go back for them because I don't really know what's going to happen. This is kind of exactly the result I want for a asteroid field. So that's that. I think I'm seeing, yeah, that looks good. So let me go for maybe 5,000. It takes a while to do it. No, it just doesn't even want to do it, but adjusting it seems to recompute. So maybe I need to do a little check about that. And that's that, I think. Yeah, it does seem like the distribution's off, doesn't it? Like over here, it just doesn't want to. I could adjust the seed. And when you do that, it just clears it, huh? Well, we'll work on it. But I think that is pretty much the effect that I want. Yeah. All right, that's the end of the video.